Hi there, folks. In this lesson, we're looking at rules of exponents involving division, all right? So we've done rules of exponents in terms of zero negative exponents. We've done some stuff with products and raising things to a power, but now let's talk about division. And just like before, you might already know these rules. You might know the shortcut here, but let me show you what this looks like. So again, a to the sixth power is like writing an a 6 times. So if I write this out 6 times, there it is. Over a to the second power, that's like writing an a twice. Now think about division in terms of like canceling stuff out. Like if I canceled out this set of a's, and then I canceled out this set of a's, all I'm left with is 4 a's being multiplied, which is a to the fourth power. Okay? If I look at the next one, same kind of thing here. X to the eighth is x being written 8 times. Whew. Over 8x to the fifth power, that's like 5 of these x's being multiplied. And now think about canceling, like these two would cancel, and this pair would cancel, and I could cancel another pair, and one more pair, and what I'm left with is x being multiplied 3 times, which is x to the third power. And then the next one, again, I'm going to do the same thing, but with a 4 this time. So here I have 4 to the seventh power. That's like 7 of these 4s. Being multiplied. Over 4 to the fifth power, that's like 5 of these 4s being multiplied. Whew, so many 4s. And now I can cancel out. 4 divided by 4 is a 1. And these guys cancel. And this pair cancels, and this pair cancels, and this pair cancels, and I'm left with 4 times itself, which is 4 to the second power. And of course, I could simplify that further. We all know that that's a 16, all right? And for our purposes right now, we're just trying to understand the rule for exponents, but hopefully that last example shows you why this is useful. Like, I don't even know what 4 to the seventh power is off the top of my head, or 4 to the fifth power for that matter. But I can do this one without a calculator using rules of exponents. So hopefully you're looking at this going, okay, I see the shortcut, Mr. Jansen. Instead of writing those out and canceling, I can just subtract those exponents. Like in the first one, 6 minus 2 is that 4. The next one, 8 minus 5 is the 3. And the last one, 7 minus the 5 is the 2. All right? So the rule when we're dividing is we can subtract the exponents. And once again, just like all of our other rules, we have to have the same base. I can't do this if one is an x and one is a y. All right? So when I'm dividing, I subtract the exponents. For example, if I look at this guy, and once again, I could write out 21 b's and then write out 10 b's and watch 10 of them cancel and see how many I'm left with. But the shortcut is I just do my rule for exponents. I subtract, and I get b to the 11th power here. Okay? The next one, same kind of thing. And the thing that's tricky about this one is when you subtract, you're subtracting a negative. So that's like adding the opposite. So this is actually x to the 19th power. And again, if you need to take that off to the side and think about it, 11 minus a negative 8. Remember, always change subtraction to adding the opposite. Now it's 11 plus 8, which is 19. Okay? The next one, I subtract the exponents. 6 minus 9 is a negative 3, so this is y to the negative third. But now negative exponents, I know that to be division, so I flip it. That's 1 over y to the third. Remember, I flip it to the other side of the fraction bar, and I make it positive. That's our rule for negative exponents. Once again, we have to deal with numbers alongside of these things with the exponents, but we deal with numbers the same way we've always dealt with numbers. Here, if I ignore the a's, it would say 10 divided by 5. Remember, a fraction bar is a division sign. And I know that 10 divided by 5 is a 2. It's always been a 2, and it will always be a 2. That has not changed. But now rules of exponents, I subtract the exponents. That's a to the first power. And if you write the a to the first power, that's fine. If you get rid of the 1 and just write it as 2a, that's the same thing. That would also be okay. I'm fine with you leaving the 1 there if it makes you feel more comfortable. Okay? If I look at the next one, again, deal with numbers the same way we've always dealt with numbers. 6 divided by negative 3 is a negative 2. And now I subtract the exponents. That's x to the negative second when I do the 5 minus the 7. But now take care of negative exponents. Keep in mind, that negative 2 is not a negative exponent right here. This guy, that's negative 2 to the first power. The only thing that has a negative exponent is the x. So this is going to become negative 2 over, it becomes dividing by x to the second. Remember, that's what negative exponents do. Negative numbers don't do that. Only negative exponents go to the bottom. So keep that in mind. If I look at the next one, once again, negative 2 divided by 2 is a negative 1. When I subtract the exponents, that's a y to the second. And you can just leave it like that if you'd like. You can leave the negative 1, or you could write it just negative y to the second. You know, in math, we tend to make a lot of invisible ones floating around all over the place, which really makes things more complicated. If you want to leave it as just a negative 1 y to the second, that is fine with me. If I look at the next one, once again, I'm going to do the division the same way I've always divided numbers. 4 divided by 2 is a 2. But now rules of exponents, I subtract the exponents, that's a to the second. When I subtract the exponents, that's b to the negative first. And now negative exponents, the only thing with the negative exponent is that b value, so I send them to the denominator. And again, you can have the 1 on there, or you can drop the 1, make it invisible. That's up to you. If I look at this one, once again, if I start looking at this thing and saying, okay, negative 5 divided by 3 is a negative 5/3, and now I subtract the exponents. Notice that x doesn't have an exponent. That means it's a 1. Remember, anytime you don't see an exponent, it's a 1. So now when I subtract the exponents, that's x to the 6th, and then y to the negative 14th. And now you might be looking at this going, wait a minute, I have this weird fraction. What do I do with that? Well, the fraction is great to have here because it already sets up a numerator and denominator for us. See, look at this. Negative 5 in the numerator, 3 in the denominator. Think about the x to the 6th. Where does it go? Well, it goes in the numerator because it's a positive exponent. Why the negative 14th? I'm going to send it to the other side. I'm going to send it to the denominator and make it positive. That's what negative exponents do. Okay? They go to the other side of the fraction bar. They become positive. We flip them and make them positive. If I look at this guy, again, this is the thing that really messes with us is when we start dealing with division, we always have to deal with fractions. Like in the last one, that negative 5/3. This one, there's a 1 out front here. So when I divide 1 divided by 8, that's literally a 1 over 8. It's a 1/8. Okay? And it's okay to have a 1/8. That's fine. And then look at some of these other variables. Here's an exponent of 1. Here's an exponent of 1. All right? If you don't see an exponent written, the exponent is 1. So now I subtract those exponents. That's going to be an x to the 13th when I subtract. Here that's going to be a y to the 16th when I subtract. Be very careful here. 10 minus a negative 6. It's like 10 plus 6. And then this is a z to the negative 3rd. Okay, 1 minus 4. But now start dealing with negative exponents. And again, don't be scared of that fraction. That fraction actually makes things really nice for us. It's already established, hey, numerator, denominator. 1 in the numerator, 8 in the denominator. Think about the x to the 13th. Where does it go? It goes with the numerator because it's positive. Y to the 16th, numerator because it's positive. Z to the negative 3rd, well, let's send it to the denominator so we can make it positive. Okay? Negative exponents go to the other side of the fraction bar and we make them positive. And that's it. And again, you can make that 1 invisible one if you'd like, or just leave it. This one, same kind of thing. Negative 2 divided by 8. Don't be scared of it. That's just negative 2 over 8. Reduce the fraction. That's a negative 1/4. Okay? And now look across at these exponents. There's a 1. The thing that's going to mess with us here, let's do it. We'll deal with it when we get there. Ready? Subtract the exponents. Be careful here. That's an a to the negative 15th. Negative 14 minus 1. That's a b to the 4th. And then c is tough because there's no c value here to deal with. So really, it's like that one stays underneath, okay? And now this looks kind of awkward. So let's just clean it up. That looks weird, right? Let's let that fraction help us out. So the c to the 4th was in the denominator. There we go. The a to the negative 15th, we're going to send him to the denominator also. And then the b to the 4th stays with the numerator, okay? It's okay to write something in a little bit of a strange way at first, as long as we clean it up in the end. It's almost like if I were to kind of grab this guy. I don't know if it'll let me. If I could just grab that 1/4 and scoot it down. Ready? Now does it almost look better? Okay? Yeah, let me just extend that fraction bar. Oh, there we go. All right. And so the c to the fourth didn't have anybody to deal with, so it just stayed where it was. It stayed in the denominator. Okay. You could also think of it this way. It's like there's a c to the 0 up top. And when you subtracted those, that would give us a c to the negative fourth. The negative exponent gets sent to the denominator. Again, I think I mentioned this in another lesson, but it's very rare that we would really be dealing with these rules of exponents in this kind of context, okay? Most of the time, you will deal with exponents, rules of exponents, in more of an isolated fashion, okay? So if you can do these first 6 examples, you're in pretty good shape, okay? In a real-world context, this is how you would typically use those rules, all right? And of course, our good buddy scientific notation. Here's one of the great applications of our rules of exponents, all right? So just like before, we're going to deal with the numbers out front first. So here, 9 divided by 3 is a 3. And now I leave it as times 10 raised to some power. To deal with the 10 raised to a power, I just subtract the exponents. I'm using my rule of exponents. That's an 8. And now this is in scientific notation. That one is done, okay? Same thing with this next guy. I deal with the numbers out front first, okay? So when I deal with the numbers, I do the 4.2 divided by 2 gives me a 2.1. But now I leave this as times 10 to a power. I subtract the exponents. 18 minus a negative 6. Be really careful with the signs here. That's a 24, okay? Remember, minus a negative is like plus a positive, so that's like 18 plus 6. And now this is scientific notation. There's nothing else I have to do. And keep in mind, remember, when we're dealing with scientific notation, our answer has to end in scientific notation, all right? So like if I look at the next one, 1.8 divided by 9 is a 0.2. And now I subtract the exponents, that's a 4. But now the problem with this one, it's not written in scientific notation. Scientific notation, this would have to be a 2.0 or just a 2 there, okay? That decimal's not in the right place. I have to put it in the right place for this to be in scientific notation, okay? And now because I moved the decimal that direction, this is now going to be a 10 to the third power, all right? When you think about some of the ones we've adjusted before, it's like I moved the decimal one more spot, so I increased the exponent. Well, here I kind of moved the decimal one less spot. It's like the decimal was too far, so I moved it back one more, so I decreased that value, okay? And again, if you're not sure, take this guy right here and literally move it 4 decimal places, write it in standard form, and then rewrite it back in scientific notation, and I guarantee you're going to come up with this, okay? If I look at the next one, once again, I'm going to divide those numbers. The 2.4 divided by 6 is a 0.4. I subtract the exponents. That's a 10 to the negative 12th. And just be careful, once again, negative 3 minus 9. Now, that's not in scientific notation. Instead of that decimal being here, I have to move it to here. Okay? So it's like I moved it back 1. But keep in mind, because this is a negative exponent to start negative 12, okay? That's like moving my decimal backwards. So it's like I moved it backwards 1 more. So now it's a negative 13, okay? And again, if you're not sure, take this guy and move that decimal 12 spots this way, and then count back to where you need to go. To count to here would be 12, here would be 13, all right? Write it in standard form and then back in scientific notation if you're not sure how to adjust that exponent, okay? And the last thing we're going to look at when we're talking about the division here is if we have a fraction, an entire fraction raised to a power, I just raise every piece of that fraction to the power. Okay. For example, when I look at this guy, I do x to the 4th raised to the 2nd power. And now this is my rule from the other day. When I raise something to power, I multiply the exponents. That's x to the 8th. All right. But then I also have to do the 5 raised to the 2nd power, which is a 25. All right. Anytime I have parentheses, it's like that exponent applies to everything in that parentheses. Okay. So I have to take it one piece at a time. Same thing here. I'm going to raise the x squared to the 4th power. So I multiply the exponents. That's x to the 8th. I'm going to do the y to the 4th to the 4th power. So I multiply the exponents. That's a 16. And again, that's our rule from the other day. And then here, z to the 3rd power raised to the 4th. When I've raised it to a power, I multiply the exponents. That's z to the 12th. Okay. And that's it. This becomes really, really tricky when we start throwing negatives in here, okay? And my recommendation, if you have a negative on the outside of parentheses, normally I take care of negative exponents last, except when that negative exponent applies to a whole chunk of stuff. When there's parentheses with the negative exponent, let's do that negative exponent first. Watch this. So this negative exponent basically means I flip this entire fraction, okay? So I can flip this whole fraction and make it this. Make it 4z to the second over x to the sixth, y to the eighth. And now because I flipped the whole fraction, I can make that a positive 2. Okay, that's the easiest way to deal with a negative exponent that applies to a bunch of stuff. Okay, is just flip the whole thing right away. And now let's do each of these. 4 to the second power is a 16. My rule of exponents is I multiply the exponents. That's z to the fourth, x to the 12th, and y to the 16th. All right, we're back to that rule from the other day. This one, same kind of thing. And students will get confused here because, I'm going to flip this fraction. So I'm going to do the 3z to the negative fourth. And notice, I don't deal with any of these negative exponents that are inside the parentheses. Okay, I'm just flipping that whole thing. The whole thing flips because of the negative that's on the outside. Okay, that negative applies to the entire set of parentheses. So I flip the entire set of parentheses to use that negative that's with the 3. Now I'll start using my rules of exponents. Ready? 3 to the third power is a 27. This is going to be z to the negative 12th. I multiply the exponents. And notice I'm not dealing with these other negative exponents yet. Here, multiply the exponents. That's a negative 21. Here, multiply the exponents. That's a 15. And now I'll deal with those negative exponents. So right here, the z goes to the bottom. The y stays where it is, and the x moves to the top. We switch them to the other side of the fraction bar and make them positive. All right. This is about as complicated as these examples get right here. Okay. If you can do these, you can do any of them. But once again, most of the time these rules are used in isolation. So when we're dividing, divide numbers the way you've always divided numbers. But the special rule for exponents is that when you're dividing, you subtract the exponents. Okay. And when we apply that to scientific notation, it's the same thing. Divide the numbers, subtract the exponents to get your new value, your new exponent for the 10. Okay?